So we are starting our lecture number 7. In this, we have to cover the physics topics for the test for EST Physics FDE Islamabad 2024. Okay, so here you can get complete notes for EST Physics. Okay, Federal Directorate of Education Islamabad FDE. So the Federal Directorate of Education Islamabad basically has a detailed syllabus for elementary school test EST, and this is for EST physics examination. And you know that for the physics paper concerned, 60% marks is from your course, like from physics, and 20% is pedagogy, and the remaining 20% is from English. So in this physics section we will cover those topics which are very important and mostly repeated MCQs we will discuss in this lecture. Whereas physics is concerned, the main topics will come from, first of all, mechanics. In mechanics, the questions comes from kinematics, dynamics, and gravitations. Whereas kinematics is concerned, the questions related to kinematics is motion in 1 and 2 dimension, displacement, velocity and acceleration, equations of motion and projectile motion. Okay, and dynamics, the questions came from Newton third law of motion. Okay, Newton law of motion, friction, tension, normal forces, circular motion, work, energy and power, and the conservations of energy and momentum. Whereas the gravitation is concerned, your Newton laws of gravitation, gravitational field potential, and satellite motions, these will topics will came. Okay. Now move on. Our second topic, which is very important for this test, is thermodynamics. So thermodynamics in the first topic will is the temperature and heat, and the subtopics which are mentioned in these questions come from temperature scale, thermal expansion, and heat transfer methods like conduction, convection, and radiations. Okay, whereas your laws of thermodynamics is concerned, your zeroth, first, and the second laws of thermodynamics are very important for this test, and coordinate engine very important, and entropy. Okay. So the third topic, the questions comes from is waves and oscillations, simple harmonic motion, like the characteristics of SHM, energy in SHM, and damped and forced oscillations. Okay, while your second part is for wave motions, there are types of motions, many questions, and there are questions from wave speed, frequency, and wavelength. And there are several questions we see in past papers like sound waves and Doppler effects. Okay. Also, many questions came from the electromagnetic wave, spectrum of electromagnetic wave, and their properties. Whereas the fourth topic is optics is concerned, so there is geometrical optics. Subtopic is very important along with the physical optics. In geometrical optics, reflection and refraction, mirror and lenses and optical instruments. And physical optics, interference and diffraction and polarizations. The questions came from these topics from the chapter of optics. Okay, now move on towards our next main topic, which is the electricity and magnetism. In electricity and magnetism, the questions mainly came from these subtopics. First of all, the electrostatics, Coulomb's law, electric field and potential, capacitors and capacitance. Okay, and electrical current, electricity. Okay, Ohm's law, series and parallel circuits, and similarly electrical power and energy. And from magnetism, magnetic field and forces, electromagnetic induction, and AC and DC generators and motors. Okay, now move on towards our modern physics. Okay, so modern physics, the questions, first of all, most of the questions came from the quantum physics, like the topics of photoelectric effect, wave duality principle, and atomic model and spectra. Whereas nuclear physics is concerned, then topics came from radioactivity and decay laws, nuclear reaction and energy, and applications of nuclear physics. So these are basically the topics from which all of your physics EST paper comes from. And in this video, we will cover all these topics step by step. and all these MCQs related to these topics, and those MCQs will only cover which are just repeated many times in last past papers. So this is a complete PDF of 96 pages. If you want this PDF, we made this PDF for you for a very minimal price. If you want this PDF, just leave a comment below, or you can contact. I can leave my WhatsApp number in the description. You can just go there, and for the sake of minimum price, you can get this PDF. Along with that, I have also other subjects PDF for maths, English, and Islamiyat, and any subject you want. We are already made that respectfully. Okay, so if you want, you can leave the comments below. Okay, the number is mentioned in the description. So these are basically the recommended books. So EST test, this is for 14 scale. So mostly the course came from 9, 10, and first second year course. Okay. So these are basically the reference books, not follow any other external book. Okay. So now move on towards our chapter number 1, which is mechanics. Okay. So first of all, we will cover chapter number 1, mechanics. So here you can see, first of all, we define the physics. What is basically physics? So physics is the natural science that study matter, energy, and their fundamental forces. It's aimed to understand how the universe behaves at every scale, from the smallest subatomic particle to the largest galaxies. Okay, physics uses this scientific method to develop the test theories and models that explain physical phenomena. Okay, now move on towards our major branches of physics. This is very important. These are basically the branches of physics. First of all is the classical mechanics. What is classical mechanics? The study of motion, force, and energy, typically dealing with objects larger than atomic scale. If you are concerning with the objects that are larger than the atomic scale, then you are in the classical mechanics. Okay, and moving at the speed which is much less than the speed of light. Okay, so this you are in classical mechanics. And what is thermodynamics? Basically the study of heat, work, and temperature, and statistical behavior is basically called as the thermodynamic. While what is electromagnetism? And this is the study of definitely electric field as well as the magnetic field, how they behave and interact. And the optics, basically the study of light and their interaction with the matter, how reflection, reflection, and diffraction begin. Okay, what is acoustics? Acoustics is basically the study of sounds and vibration. Okay, this is for sound physics. Okay, quantum mechanics, so this is for a subatomic scale, mean fundamental scale. So if you want to study the matter and energy interaction at smaller scale, so you have to study the quantum physics or quantum mechanics. What is relativity? Okay, those the study of objects moving approximately equals to the high speed and approximately equals to the speed of light. Okay, and what is nuclear physics? And nuclear physics is basically the study of the components and behavior of atomic nuclei, means study of subatomic particles. Okay, and particle physics is basically the study of fundamental particles and the forces of interaction between them, how forces interact in small scale. Okay, now what is the astrophysics? Astrophysics is basically the study of properties of celestial bodies, stars, galaxies, milky ways. Okay, universe and whole. So these are about the astrophysics. Now move on towards our chapter number 1, MCQs. So you can see there are many MCQs. In each chapter we make 20 MCQs. As I mentioned, there are total, you can see here how many chapters: one, 2, 3, 4, 5, 6. 6 chapters. So there are total 6 chapters, and each chapter we cover 20 MCQs. So there are many, so it becomes total of 120 MCQs. Okay, so let's start. So we have complete solution of these MCQs, and these are the most repeated MCQs in the past EST physics papers. Okay, so first of all, which of the following quantities is a vector? So from in these, which is vector? Speed is scalar, distance is scalar, temperature is scalar, but yes, velocity is a vector quantity. Okay, because it has direction as well as it has magnitude. Okay, so velocity is a vector quantity. The unit of force in international system of UI. So everyone knows the unit of force is Newton. Okay, which law states that for every action there is an equal and opposite reaction. So everybody knows that this is the Newton third law of motion. Okay, so here is the correct answer, Newton third law. To every action there is an equal but opposite reaction. So what is the speed of light in vacuum? We know that the speed of light in vacuum is basically 3 into 10 raised to power 8 meter per second, means 3 lakh meter per second. Speed of light in any medium, in vacuum or in any medium, is a constant. So it remains same, 3 multiplies by 10 raised to power 8 meter per second. Okay. Which phenomena explains why sky appears blue? This is a very important phenomena, and we know this is due to the scattering of light. Okay, light only scatter blue color because you know that light is a combination of many colors, but our sky only scatter the blue color and it reflects. Okay, the other colors. That's why we only see the blue color. So the correct answer is scattering. The sky appears blue due to the scattering phenomena. The first law of thermodynamics is a statement of conservation of. So, our first law of thermodynamics is basically the conservation of energy. So, the correct answer is energy. Okay. In an electric current, Ohm's law is given by. So, the formula relation of Ohm's law is very common, and we know that it's V equals to IR. Okay. Which type of electromagnetic radiation has the highest energy? So the highest energy is basically the gamma rays. X-ray is higher, but the most highest energy the ray has is the gamma rays. Okay. The process of splitting a nuclei into two or more small nuclei is called what? You know that if a nuclei is split into smaller nuclei, the process is called fission reaction. So the answer is B, fission. And if small nuclei combines to form a large nuclei, then this is called fusion reaction. So if it splits in more subatomic nuclei, then this is fission reaction. Which device converts electrical energy into mechanical energy? So motor is a device which is connected with electric, which work with the form of electrical energy, and it can provide with the mechanical energy as an output. So motor is a device which converts electrical energy into mechanical energy. The phenomena where light bends around corners and edges is called what? Reflection is basically the reflection. Refraction is when the if a light bends and after going into denser medium it bends 90 degree, and so diffraction is the answer. So in diffraction basically you can know that the double slit experiment, like how light bends after they passing through let's suppose one slit or two slits. So the bending of light from those slits is basically the phenomena of diffraction. This is not interference. Okay, this is diffraction because light bends like a diffraction pattern. Which particle is not found in the nucleus of an atom? Yes, we know electron is not inside the nucleus of an atom. It's in the outermost shell, while proton and neutron are inside the nucleus, and inside proton and neutron there are quarks. The fundamental force responsible for holding the nucleus together is, yes, strong nuclear force. So what binds the nucleus together? Yes, the strong nuclear force. The strong nuclear force is basically between the nucleus. Which of the following is a unit of power? Yes, we know that. Watt is the unit of power. Which principle states that pressure applied to a confined fluid is transmitted undimensioned throughout the fluid? Yes, basically the Pascal laws tells us about how we apply pressure, okay, to a fluid to transmit undimensioned throughout the fluid. So the answer is Pascal's law. What is the phenomena where a wave changes direction due to the change in the speed? So if there is a change in speed, so wave changes their direction. So this is a refraction, because in reflection there is no change in the wave. Your incident wave must equal to reflected wave. But in refraction, your incident is not equal to refracted. Means your refracted is changed. There, that's why the answer is refraction. Which type of wave requires a medium to travel? Yes, we know that sound waves need, but here is no option of sound waves. So mechanical waves need some medium to travel. Your light waves do not need any medium to travel. Okay, and gravitational wave also don't need any mediums. Electromagnetic waves, electromagnetic basically light waves, so these also don't need any medium. So only the need of medium is required for mechanical waves. So this is the correct answer. Which of the following particle is responsible for the electrical properties of material? Yes. So the electrical properties of material is defined by their electron property. So how many electrons a material has depends upon their electrical properties. More the electrons they have free electrons, the more they will conduct. So basically the electron is the correct answer. Which instrument is used to measure the electric current? Yes, amperes. Okay. Or you can see ammeter. Galvanometer is also a device, but here is no option for the galvanometer. Voltmeter is to measure the voltage. Ohm meter is to measure all the concerns voltage either, and barometer is something else. And the correct answer is the ammeter, which is used to measure the large amount of current. The total internal resistance in parallel circuit is, okay. The total resistance in parallel circuit is always less than the smallest individual resistance, because once you connected your resistance in parallel, and when you find the total resistance is always basically less than the individual resistance, okay, in case of parallel. But in case of series, your total resistance is greater than the individual resistance. So keep remember this when you are connected your resistors in parallel circuits, and you connected in parallel, so the total resistance is always less than the smallest individual resistance. Okay, so that's all for this chapter. Now move on towards our next chapter, which is the motion in one and two dimensions. Okay, so in this you can see there are many topics like motion in one and two dimensions. So first of all, motion in one dimension. So motion in one dimensions are concerned with the displacement, velocity, and acceleration. Okay, and displacement is basically the change in position of an object, and we can find displacement by this formula. Okay, displacement is this, and we can find but this final distance minus initial distance. So what is velocity? Velocity is basically the change of displacement. Okay, rate of change of displacement, and this can be calculated by the v equals to rate of change of displacement del x by del t. Okay, acceleration is concerned is basically the rate of change of velocity. Okay, and we can find acceleration by find expression of rate of change of velocity means del v by del t. So equations of motion, we already know that the first equation of motion is Vf equals to Vi plus At, where this Vi is denoted by this U and final velocity is denoted by this V sign. So this is our first equation of motion. And what is our second equation of motion? S is equals to VIAT plus 1 by 2 AT square. This is our second equation of motion. And what is our third equation of motion? Vf square equals to Vi square is equals to 2As. So these third equations of motion are also very important. So what is free fall? Free fall basically this is a topic in which your object move under the influence of gravity along with an acceleration, and your acceleration body attain is 9.8 into 10 is 9.8 meter per second square. Okay, this is the free fall system. So motion in two dimensions, so your displacement, velocity and acceleration change in two components like x and y. So now you have x component as well as the y component of acceleration, velocity as well as displacement. So you can see here. Okay. In this motion in two dimension, the very important topic is the projectile motion. Most of the problems MCQs based on the this topic come from the projectile motion. So basically, what is projectile motion? Basically, a form of motion where an object move in a literally symmetric parabolic path. Okay, literally symmetric in a parabolic path. The only force of significant that acts on the object is the gravity. So the only force acts while in the this projectile motion is gravity, and acts downward because you move the object forward, and so the gravity always acts downward. Okay, to cause downward acceleration. So there are horizontal motion and there is vertical motion. So in horizontal motion, you know that the constant velocity, it will move with constant velocity. Horizontal motion is this motion and vertical motion is this motion. So vertical motion you have constant acceleration. Okay, and uniform circular motion, you also know that there is another topic for the 2D, which is the uniform circular motion, means centripetal acceleration. We know the formula of when a body moves in a circle, centripetal acceleration is applied on that, and centripetal acceleration is equal to V square by R. Okay, this is a very important formula. Many problems came from this formula. Now move on towards example problems and solutions. So motion in one dimension, you can see a car accelerates from rest. Let's suppose a car accelerates from rest having initial velocity acceleration is 2 meter per second square. Calculate the velocity after 5 seconds. So how you can calculate this? So you have to calculate the velocity and the initial acceleration is given. Yes, you use the first equation of motion. Vf equals to calculate the velocity after 5 seconds, means you have to find the final velocity. So 5 v equals to Vf equals to Vi plus At is the formula. So V becomes equals to, because your car accelerates from rest, that's why their initial velocity is 0 plus which is 2, which is the acceleration multiplied by time it took. So it becomes 10 meter per second. So how projectile motions problems came are like this. A ball is thrown horizontally from a height of 20 meters with an initial velocity of 10 meters per second. So this is the initial velocity of the ball at which it is thrown, and the height from where the ball is thrown is 20 meters. Calculate the time taken. So you have to calculate the time taken. Definitely you have to use this projectile motion. Time taken to hit the ground and the horizontal distance you also find. So you can find first of all time to hit the ground you can find by this formula. V equals to 1 by 2 gt square. Okay, you can see this formula. This is basically the formula of time of flight, 1 by 2 gt square. Your y dimension height is given, which is 20. 1 by 2 g gravity is 1.9.8 t square. So we have to find the time, so t square and all other aspects to the other side. So t square becomes equal to 40 by 9.8. So take a square root, you will get 2.02 seconds. Okay. And horizontal distance you also have to find. So horizontal distance can be used by simple formula. You know that S equals to Vt. So distance equals to Vt if time is already find it. And so by using that time and the initial velocity which it has, which is 10, so you can easily get the horizontal distance. Okay, now move on towards our problems of these, which are very important problems and mostly came in many past EST physics papers. So these are total of 20 problems. You can see we will cover this all in this video. Let me show you. This is a total of 10 and some of other problems are mentioned here. You can see. Okay, so let's start. This is a complete PDF. If you require this PDF, you can just drop your comment and I will leave my number in description below. You can contact me and get this in a symbol. What is the SI unit of acceleration? We know that it's meter per second square. An object is moving with a constant velocity. What is the acceleration? If a body is moving with constant velocity, so there is no acceleration. So keep remember this. Some of students say that if a body is moving, so the acceleration is always 9.8. No, if a body is moving with constant velocity, or if a body has velocity 0, then the acceleration is also 0. A car travels at 20 meter per second for 10 seconds. So this is the velocity of car and this is the time it takes. What is the displacement? Okay, you know that distance equals to S equals to Vt. So this is V and this is T. Multiply 20 into 10, you will get 200. So the answer is 200 meters. Which of the following is true for an object in free fall? So if an object is fall under the free fall, I already mentioned you, so it has an acceleration of 9.8 in the downward direction, because acceleration is always, gravitational acceleration always directed towards downward, not upward. An object thrown horizontally from a height from follows a path like parabola. This is from projectile motion. Okay, in projectile motion the horizontal component of velocity, this is very important. In projectile motion the horizontal component of velocity is remains constant, only the vertical component of velocity changes. Which is horizontal component? This is the horizontal component and this is straight, and this vertical component of velocity changes, but in projectile motion the horizontal component of velocity remains constant. So you can see remains constant, the horizontal component. For an object in uniform circular motion, the direction of acceleration is, so if a body is circulating with a uniform motion, then the acceleration is always directed inward. So the answer is yes, radially inward. Because you know that this is due to the centripetal force, because if a body is moving in circular motion, the acceleration is always directed towards the center, and so that's why this is so called as the radially inward. A ball is thrown with an initial velocity of 20 meter per second. Now the initial velocity of ball is mentioned at an angle of 30 degree. Angle is also mentioned uh, to the horizontal. What is the horizontal component of the velocity? So you have to find the horizontal component of the velocity. So how you can find? Because we have to find the horizontal component. So the for the horizontal component, so the formula is for this is V equals to sorry, the distance is basically, you can say, is equals to V multiplied by cos of theta. Okay, so as the velocity is 20, so 20 multiplied by cos of 30, because this is the horizontal component, that is by cos of. So we know that the cos of 30 is equals to what? under root 3 by 2, and under root 3 by 2 is basically 0.8. Okay, and when 0.8 is multiplied by 20, the answer is 17.32. So this is the correct answer. The time of flight for a projectile launch as an angle theta with an initial velocity of v naught is given by. So what is the expression of time of flight in projectile motion? So the correct answer for the time of flight is this, which is this 2v naught sine of theta, okay, not cos expression. 2v naught sine of theta divided by g. So this is the correct answer. Okay, this is the expression of time of flight in projectile motion. 2v naught sine of theta divided by g. Okay, a stone with an initial velocity of 50 meter per second. Now initial velocity is given and angle is also given. The horizontal with again now this is the horizontal. What is the maximum height? And now you have to use the gravitational acceleration 10 meter per second square. Now you have to find the maximum height. How you can find? So the formula of the maximum height of a projectile is h equals to v square sine square theta divided by 2g. So the initial velocity is given, which is this, which is v. So v square. So the how you can find? So it becomes 50 square multiplied by sine square 45 divided by 2 because in denominator is 2g, so 2 multiplied by 10. So the answer you got is 62. Okay, so you can find from this. So the formulas of times of flight, which is this, and the formula of the maximum height, you keep remember. Okay, these are very important. So this is now displacement, velocity, and acceleration. We already know that. Okay. These are the equations of motions. Now these are the examples like a car travels 60 kilometer north, then 90 kilometers south. What is the displacement? So initial positions you take 0 kilometer, final position is this. Okay, because a body always starts with initial position of 0 and your final position is this. First of all, your car travels 60 north, so 60 minus 90 south, so minus 90 you will get minus 30 kilometers, means 30 kilometers south. Okay, so the displacement is minus 30 kilometer south, because you know that the formula for the displacement is final position minus initial position. So final position is this 60 minus 90, it becomes minus 30 minus 0, so it remains minus 30. Okay, if you want to find velocity, how you can find? So a runner completes 400 meter lap in 50 seconds. Now the distance is given, which is 400 meter, and the time is also mentioned where you have to find the average velocity. To find the average velocity, again you first of all need the displacement. So the displacement should be 0 meters since the runner returned to the starting point. Okay, because a runner completes a 500 lap in 50 seconds. So displacement is basically 0. And the time it takes is 50 seconds. So if you want to find the average velocity has a formula of the displacement divided by time. So displacement is 0 divided by time, which is 50. You will get 0 meter per second. Okay, you ask the question why 0, because you can see this is a lap, because a runner starts a lap from a point and it comes back to the same point, means from where it starts it comes back to the same point after 50 seconds. Means it revolves 400 meters lap, but the displacement it covers is same, is zero, because it comes back to the same point. That's why it is zero. If it not comes to its original same initial point, then your displacement is not zero. Okay, keep remember this crucial point. So we're finding the acceleration. Let's suppose a car accelerates from rest. Now again your initial velocity is 0 to 20 meter per second, which is your final velocity in 5 seconds time. So the final acceleration is basically Vf minus Vi divided by t. So Vf minus Vi 20 minus 0 divided by t. So 20 by 5 it becomes 4 meter per second square. So some problems really can be come from this, like displacement calculation. A cyclist travel 10 kilometer east. Now you can see a cyclist travel 10 kilometer east and then travel 50 kilometers north. What is the displacement? So how you can find the displacement if a cyclist travel 10 centimeter east and 15 kilometer north? So you just use the Pythagoras theorem. Means under the root a square plus b square. A is basically just 10 square plus 15 square. 10 square is 100 plus 15 square is 225. It becomes under the root 325. And your answer is near about 18.03 kilometer. Okay. So this is how you can find the displacement. A car moves an initial velocity is 5 meter per second. Now initial velocity is this 5 meter per second, and the acceleration at 2 meter per second square. Okay. For 4 seconds. For 4 seconds time is also given. What is the final velocity? So you have to use the first equation of motion. Vf equals to Vi plus At. So putting values you can easily get the initial velocity. And the acceleration calculation, how you can find? So a train deaccelerates. Deacceleration means negative acceleration from 30 meter per second to 10 meter per second in 5 seconds. So now in this scenario, your final velocity is this, because our car decelerates from initial velocity is 30 and final velocity is 10. So 10 minus 30 divided by the time it takes, it becomes minus, because this is the acceleration. Okay. Now let's start the MCQs related to these topics. Okay. What is forming a scalar quantity? So basically, the scalar quantity is the only speed. Okay, scalar quantity is the only speed. Acceleration is a vector quantity, velocity and displacement is a vector quantity, but your speed is a scalar quantity because it has only magnitude, not direction. Okay, what is the SI unit of displacement? You know that the SI unit of displacement is meters. An object moves with a constant velocity. What is the acceleration? As I told you before, if it moves with constant velocity, so acceleration always be zero. Okay. Which of the following correctly describe the relationship between the displacement, velocity, and the acceleration? So answer is basically the velocity is the rate of change of acceleration. Okay, because this describes the relationship between displacement, velocity, and acceleration. So velocity is the rate of change of acceleration, and uh, displacement is the rate of change of velocity. Okay. Sorry, this is this one. Velocity is the rate of change of displacement, not acceleration. Okay, because velocity is the rate of change of displacement, and acceleration is the rate of change of velocity. Okay. If a car accelerates from rest, okay, and has a constant rate, and has a constant if a car accelerates from rest at a constant rate of 3 meter per second square. This is the acceleration is given, constant acceleration, which is 3 meter per second square. What will be its velocity after 4 seconds? So you have to find the velocity after 4 seconds, means you have to find the final velocity, and the initial velocity is given and the acceleration is given. So you can definitely use the first equation of motion to find this, and it will came 12 meter per second. Okay, now move on towards this equations of motions. We already know how about equations of motions. This complete PDF available. If you want, I mentioned my number in the description. You can contact me and you can get this document in a very minimum price. Okay. So the example problems are these. Problem number one, using the first equation of motion, how you can find. So let's suppose. So the problems related to first equation of motion is like this. A car starts from rest and accelerates at 3 meter per second. Now initial velocity is 0, Vi is 0, and acceleration is 3, and the time is 5. So 5 multiplied by 3, it becomes 515 meter per second. As Vf equals to Vi plus ATV, because we are using the first equation of motion. Okay. Uh, Problem number two. Let's how problem came from the second equation of motion. A car moving with an initial velocity of 5 meter per second, having an acceleration, and the time is given. What is the displacement? So if displacement is required, means distance, so you have to use the second equation of motions. Now the initial velocity is given, which is 5. So 5 multiplied by time, which is 4, plus 1 by 2, acceleration, which is 2, multiplied by time square, 4 square, you will get 36 meters. The how problems came from the third equation of motion. A train deaccelerates from 30 meter per second to 10 meter per second over a distance of 200 meters. What is the acceleration? So if acceleration is required, so how you can find from the third equation of motion, Vf equals to Vi plus 2as. So here the final velocity is, which is given, which is 10, and the initial velocity, which is 30, plus 2as. To a we have to find, and as this is given, which is 200 meters. Okay. So we can find by this equation. So because the acceleration is decreasing, so you are getting the retardation, means deceleration. So the MCQs related to these topics are mentioned below. Let's start. An object starts from rest, means and accelerates uniformly. Okay. Which equation of motion would you like to find the velocity? Very important. If a body it starts from rest, okay, this means their initial velocity is 0. Okay, so if a body starts from rest, means initial velocity is 0, and having some time, so we can easily calculate the final velocity with the help of the first equation of motion. So the answer is this. Which of the following equation is used to find the displacement? As I told you, to find the displacement, you always have to use the second equation of motion. So the answer is this. A car accelerates uniformly from 10 meter per second to 30 meter per second. This is our initial velocity, and the final velocity is this. Our distance of 100 meters. Okay. What is the acceleration? So how you can find the acceleration? You have to use the third equation of motion, which is 2as equals to vf square minus vi square. So this is vf square minus vi square. Okay. Because you know that the third equation of motion is vf square is equals to vi square plus 2as. So if you want to find the acceleration, so 2as becomes equals to vf square minus vi square. So putting the value of Vf is this, Vi is this, and distance is given, you can easily find the acceleration. And that acceleration is equals should be 3 meter per second square. Okay. An object thrown vertically upward with an initial velocity of 20 meter per second. Now the initial velocity is given. Using the third equation of motion, now it mentioned what is the maximum height reached. Now means you have to find the distance, and you have to use the acceleration value is g equals to 10. So you can easily find by using third equation of motion by putting the values of initial velocity, which is 20, and because it has to reach the maximum height, you have to find the s, because it goes vertically upward, so final velocity must be 0. So you have to put vf equals to 0. Vf is 0, Vi is 20, and acceleration is 10 meter per second square, and the distance s you has to find, you can easily find by the third equation of motion. Okay. Which equation of motion? So the answer you get is from solving this is 20 meters. Which equation of motion does not involve time as a variable? So we know that our third equation of motion has no time involved in this. Now move on towards our next, okay, which is chapter about the projectile motion. So in this, projectile motion is basically a motion when your body along follows the curved path under the action of gravity. Okay, the path followed by a projectile is basically called as the trajectory. So the components of motions are, there are two components. First of all is the horizontal component, which is the x direction, and the vertical component, which is the y direction. So horizontal components, you take this. So the horizontal component is uniform for the velocity, Vx remains constant. I already mentioned you before. In the case of projectile motion, the horizontal component of velocity remains constant. Okay, and there is no acceleration in the horizontal direction, assuming air resistance is negligible. There is no acceleration. So the only component is the in x direction is the, you have to use x equal v equals to v naught cos of theta. Okay, for the case of horizontal component of velocity to find. And for vertical component, which is the y direction, the vertical motion is uniformly accelerated motion with constant acceleration due to gravity. In vertical component, you have to use v naught sine theta. So vy equals to v naught sine theta, but also minus gt. Why minus gt? Because it is under the action of gravity. Okay, so y becomes equals to vertical component is basically equals to v naught sine theta t minus 1 by 2 gt square. Understood? V naught sine theta minus 1 by 2 gt square, where v naught is basically the initial velocity. You have to use the gravitational acceleration, which is 9.8. Okay, and the trajectory of path, which is the parabolic, definitely should be equals to y equals to x tan of theta minus gx squared divided by 2 v naught cos of theta square. And the time of flight formula is very important. You have to remember this formula. So what is the formula of time of flight? This is this 2 v naught sine theta divided by g. And what is the formula of maximum height? You also have to remember this v naught square sine square theta divided by 2g. And what is the formula of the range? Range formula is again v naught square but here sine of 2 theta divided by g. So these three formulas are very important. You have to remember these three formulas: time of flight, which is this, maximum height, which is this, and the range formula, which is this. So keep remember these formulas. So time of flight is t equals to 2 v naught sine of theta divided by g. Maximum height in this is basically you have to use v naught square sine square theta divided by 2g. Okay, and in horizontal range it is basically equals to v naught square sine of 2 theta divided by g. Now the problems, sample problems like this, you have to calculate the time of flight and range. Okay, so these are the formulas you have to use. So a projectile is launched with an initial velocity of 20 meter per second. Now the initial velocity is given and the angle is also given. Now what you have to find? You have to find the time of flight and range. You know that the formula of time of flight, which is this 2v naught sine theta divided by g. V naught value is mentioned, which is 20, and angle is also given, which is 30 divided by 9.8. Okay, so it becomes this t equals to 2.04 seconds. Understood? Now the second part you have to find, and your time of flight is equal to 2.04 seconds. The second thing you have to find is the range, and you know the formula of range is v naught square sine of 2 theta divided by g, and the all values are given. So after calculating, you can easily find, you know, that sine 60 is equal to under root 3 by 2 divided by 9.8, and that's all. So you will get the range, which is 35.4 meters. Okay. The next example is basically the you can find how you can find the maximum height. So for that, you know the formula for the maximum height. We know that v naught square sine square theta divided by 2g. So it's same scenario, which is vi is 20 and theta is 30, and the gravitation is 9.8. So you can get the value of range, which is 5.1. Okay. Now the practice problems is this. You have to find the time of flight. So let's suppose a ball is thrown horizontally from a height. The height is 45 meters. Okay, this is the height of from where the ball has been thrown, with an initial velocity is mentioned, which is 5 meter per second. Okay, calculate the time it takes to reach the ground. In this scenario, there is no angle is given, but you have to find the time of flight. So we have to use this formula, which I mentioned you here, the vertical component. Okay, so because in this scenario, you can see a ball is thrown from a height which has initial velocity is this, and you have to find the vertical component, means time of flight. So you have to use this formula y equals to 1 by 2 gt square. Okay, so t you have to find, the 2 multiplies to the other side and g divides. So you can, taking under root, you can easily find the time, and that is equals to 3.03 seconds. Okay, if angle is not given, so you can use this formula y equals to 1 by 2 gt square to find the time of flight. Okay, now how you can calculate the range. A projectile is launched with an initial velocity, which is 25. Initial velocity is given 25 meter per second. And now angle is also given, which is 45. To a horizontal, calculate range. So you know the formula of range, very important, very easy. R equals to v naught square sine of 2 theta divided by g. So putting the value of initial velocity, putting the value of theta, and g is remains constant, which is 9.8. You will get the range value, which is 63.78 meters. Okay. Now move on towards the practical problems. which came from the previous EST physics papers. Very important. So the MCQs on projectile motion is, what is the shape of trajectory in projectile? Definitely we know that it's parabolic. Okay. In the absence of air resistance, the horizontal component of projectile motion remains constant. We know that the horizontal component in the absence of air resistance is always constant. Okay. What is the horizontal range of projectile launched at an angle of 45 degree with an initial velocity of this? Now the initial velocity is given and the angle is given, so you can easily find, because you know that the range formula. The range formula is this: V naught square sine of 2 theta divided by g. So putting the value you can easily get, and the answer you get is 40 meters for a projectile launched horizontally. Okay, now your projectile launched horizontally. Okay, the vertical displacement after 3 seconds is, now you have to find the vertical displacement. Okay, after 3 seconds, and gravitational acceleration you have to use this. Time is given and the gravitational acceleration is given, means g and t is given, you have to find the displacement. Okay, so how you can find, again the same formula, y equals to 1 by 2 gt square. So from where you can easily find time of flight of projectile depends upon, as I mentioned you before, the time of flight basically only depends upon the vertical component. So the answer is the only vertical component of velocity, not depends upon the horizontal component. Okay, only depends upon the vertical component of the velocity. Now this is our chapter number 2. We already covered chapter number 1. Okay, this is our chapter number 1, as I showed you before this. Okay, kinematics in this we already covered that all. We will cover this in our next upcoming video, and we will also cover this, and along with that we will cover these topics in our coming videos. Okay, so today, in today's lecture, that's all for today, and we cover these problems up to here we did, and in upcoming videos we will do further solve that problems. Okay, so till then you can stay connected with us, stay tuned with us. So here, page number 27 we did today, and tomorrow we will start from chapter number 2, Newton laws of motions. Okay, so till then, take care, and if you want these notes, I will provide you these notes. I will left my WhatsApp number or WhatsApp channel group, from where you will find each and every update regarding papers, regarding scholarships, and regarding those tests. If you want this notes, which contains all the problems of total of 96 pages, so you can just contact me. I will leave my number below, so I can provide you these notes in a very normal price. Okay, it's very helpful for you because these problems are only selected problems. Okay, and these problems are came in past EST physics papers. These are the collection of MCQs which are from the previous papers. So if you revise, if you can go through these problems, you will done with your 90%. Okay, we will cover also pedagogy problems and other problems in our upcoming videos. So till then, Stay connected with us. Thanks for watching this video. Don't forget to like and subscribe. Allah Hafiz.